Hello everyone, in this video I'm gonna be displaying my s- s- SVM project that I did in Python that I displayed the video before. So first let's begin the standard imports. I'll just fast forward all these codes because it might take some time. Yeah, so next what we're gonna be doing is actually I don't need the test.cv, so I'm gonna be showing you the data set that I got. So basically what this project is I'm gonna be classifying the phone into like yeah, much categories are there. Yeah, let's see it afterwards. So first I'm gonna be reading this with pandas library, the csv file, and I printed out head to make sure it worked properly. Now yeah, there are four categories of price range, like very low, medium, high, or something like that. And what I'm gonna do is downsample these downsample these samples and format into one data frame. And after I did it, now what I'm gonna do is split the data into dependent and independent variables. Like I'm gonna be splitting it to x and y variables, the data I want to predict, and what like variables or columns I need the data to be predicted. So for example, this the price range will be the data I want to predict, and rest all will be the things I want to predict it from. Yeah, and then actually like I need to uh, do a method called one hot encoding to actually split it into no add new columns. No yeah, I'll just show it to you. Yeah, so here I got new columns, like for whatever I did, whatever columns I gave. So essentially what it does is this sklearn libraries svm does not actually support categorical data like 1 0 1 2 3 4 1 2 3 in price range, so what I'm gonna do is um, add separate columns for each and every category, and if the cat mm, the particular category mm, has that data in the particular row, then it will display 1 or 0, so it might be easier to read. I don't know why it is, but it only supports binary data, so this trick is called one hot encoding. Next what I'm gonna do is train test split it. It's the best way to do it in the scale library, so I'm gonna do this and actually scale the data for train test split scales the data. No, I mean centers the data but not scale it. We need to scale and center the data to train the support vector classifier. Now what I'm going to do is like plot the confusion matrix. Note, I mean I not optimize the svc um, to like fit in the data, so that's why the confusion matrix is a bit bad. If you don't know what confusion matrix is, basically this is the labels that were predicted and true labels that were actually meant to be, and predicted labels would be like this. And actually, for example, the low category has been predicted, medium category has been misclassified as medium category 11 times, and correctly as low category 89 times. I mean, it works like that. Next, and after I did this, also yeah, whatever, I do not need to save this. Now what I'm gonna do is like optimize the parameters. So here this first let's look into the c parameter, which actually allows misclassification to happen. That's what regulation parameter means. it allows misclassification to happen in order to like predict all other things correctly. and and this gamma variable, no, parameter, what it does is actually um, hmm, can I explain it? Yeah, actually, if you don't want to fit the, if you don't want to overfit to the training data, then you use and actually kind of correctly want to fit the um, yeah, the vectors and yeah, the lines to the training data. Then you want to adjust you want to like correctly modify the gamma. And how we are doing is using a method called grid search cv that actually what can I say, like yeah, it looks through each and every form. For example, it goes to 0.5, 1, 0.1, 1.01. For example, if this is what I'm gonna look for, then it does all this, and here all this, here all this, like that. it it searches through every possibility and finds the best parameters, optimal parameters fit. Now this is what I'm gonna fit it, the extend, scale and wide train. I scaled and split it before, and here I'm gonna search it, and here are the values. 100 is the best value for 100 is the best value for regularization, best value for allowing this classification, and this is the value for fitting the mm, fitting the model to the training data. Yeah, that's an rbf. We also need to mention the kernel, which is rbf. rbf yeah, yeah, I'll explain later. So first let's train this svm, and now the results now should be very great, way better than last result. That's how it works. We not actually optimize the parameters before, that's why it not work. And next we are gonna look at how much columns we have, and yeah, we have like 21 columns. And pca is a method to shrink data. No, actually the components, yeah, is something called principal components in every data. And what we're gonna do is actually plot how much the principal components explain the data. This is how much it explains. So first, we are going to be using the top two principal components that explain it that it hold data very properly. mm, Actually, if the difference was more, like this first bar had way more and second bar had very less, then we might not expect a result that is very satisfying. But here should do good, this model. So why we are shrinking the data from 21 dimension to 2 dimensional is basically because we need to plot it to something like, yeah, this, like this. That's why into 2 dimensional graph. So here the train page 1, and we are doing, yeah, it takes some time. This takes some time. Yeah, now we got these optimal values. Now we're gonna fit these pc, yeah, these these data frames. And yeah, this is where the transformation happens from, no, not transformation, yeah, this is where the transformation happens. Now this is where I'm gonna be actually preparing the data for plotting. Now that it's prepared, let's plot it. I'll explain how it works. So this is the SVM decision boundaries. So for example, what I'm doing here is these are the legends that we need to look for. Red labels which were here, and red labels, green labels, and blue labels. And actually the reason the model is kind of bad, no, actually if you do not know how to interpret it, no, like what happens here is that these green labels mid-end model actually should fall under this. No, if it falls under this category, then it's classified as mid-end model, no, medium model. And it's if it falls under the light red category, then it is classified as low end, and high end it is classified as high end. Yeah, this is how it works. Now we are gonna do confusion matrix for this. It's kind of bad. The reason why it is very bad, one is because I have reduced it from 21 dimensions, 21 categories to a 2 categories in PCA. But if I did like second and third row or something like that, then it would have been very bad. And second reason is because there is actually no high-end model that were actually true. That means the testing data do not have any high-end models to be predicted for, not deal with those kind of things. So the high-end model in this, what's that, yeah, the high-end model category got ignored. That's why there are only 3 decision boundaries. Yeah, also I forgot to mention one more thing. The the data points that actually lie on these boundaries are known as support vectors. Yeah, that's it. Yeah, that's it. Yeah, also I forgot to explain that RBF kernel. Actually, if you want, you can also use the what's that? Yeah, I forgot the name, but you can go. You can actually do this particular thing in a particular dimension. But what RBF kernel essentially does is looks for the best the best decision boundaries in infinite dimensions. So if I have 2 coordinates and I do the radial kernel, radial buffer function, I guess, yeah, it is. If I do it, then the relationship I get, the value I get is actually it's somewhat absolute. I guess it's somewhat absolute. That's what it's just basically it. Thanks for watching. Bye bye.